we're going to do is we're going to note that it's a right triangle. So we're just going to do 3 squared plus 4 squared equals that entire side squared. So let's just do 3 squared plus 4 squared equals c squared. Well, that's just 9 plus 16 equals c squared. Well, that's just 25 equals c squared. I take the square root of both sides, and we're going to find that that c is just going to equal 5. So that's not how the book did it. I just like this method a lot more. All right, like I said, I'm just kind of shying away from that book method because it seemed overly complicated, and it's not used very often. So this one's used more often. All right, and why we use this more often is because 90% of the time, if I don't have to throw a brand new variable in, I'm not going to. All right, so the book threw in a variable y here, but we don't need to use a new variable. Instead, we could say if this is x, how can I rewrite this segment? If I know this is x and this is 5, how can I rewrite that segment that's missing? Anna?
5 minus x.
I would just do 5 minus x. Now we have to use the trick they taught us, or they told us. They kind of gave us that hint. I forgot page like 270. They talked about when you have an angle bisector, the proportional angle bisector theorem. And that states that if I have an angle bisector, which I do, because this is 45, this is 45, that means these two things are proportional to these two things. Or in other words, we could do 3 over x equals 4 over 5 minus x. Or we could do x over 3, 5 minus x over 4. Or we could do 3 over 4, x over 5 minus. We could use any one of those. What I'm going to do is I'm going to do the 3 over x, and I'm going to set that equal to 4 over 5 minus x. And if you did it the other way, you'd realize how much easier this way is just by looking at that. I didn't have to solve for y. Now I can solve for x pretty easily by using cross multiplication of the means extremes. So x times 4 is 4x. Remember, it's 3 times the whole quantity. So it's 3 times 5 gives me 15, and 3 times negative x, which is negative 3x. I would add 3x to both sides. I would see 7x equals 15. Divide both sides by 7, and we're going to see that x equals 15 divided by 7. Much easier, isn't it? Much easier than the book method way. All right, and this is going to work on a lot more problems than that book method way does. All right, so if you don't have to, try to use this trick to come up with the side rather than doing x and y. If you can't, if you have absolutely no idea how long this line is, then you have to use x and y and go for there. But I always try to use that same variable as often as you can. It just makes your life a lot easier. Any questions about what I did up here? I hope you see how much easier it is this method, and this is kind of the method that I'd like you to use. I'm realistically just going to go over 2 problems today. If you struggle with other problems, just kind of look at if either one of these 2 ways helps you solve it. Go back into it. I'm not even checking to see if you did it today. If you really struggled on it, go back into it. Keep looking at the answer key and see if you can figure it out on your own. I only really care about these 2 right now. These are the 2 that kind of are blanket problems. That if you can do these, you can generally do ones like it. You just got to figure out how is it like it. All right, so this is number 38. We did 37 in homework. In the notes. If you would have realized that. If you got stuck on that one, we actually did it in the notes of it. So we're going to do 38. We already did 37 yesterday then. Okay, so 38. I'm given this triangle. And we have 30, 25, and h. And that hint is basically a hint I told you. If at all possible, write everything in terms of the same variable. So I don't know the length from t to u, so I'm going to call that x. And that means this total length is going to be x plus 11. And most of you should have this done. It was in your homework, so you should have your homework out looking at it or making changes along the way. No one should just be staring at me. I now have two right triangles. I have this little sliver right triangle, and I have this big right triangle right here. So we're going to use that information to actually solve for our x variable. Where did I throw it? Oh, I didn't even do this one. Okay, so we are going to, first of all, let's do that little sliver one. So I'm just going to do this little sliver one where the hypotenuse is 25. My sides are x and h. So that means I'm going to have x squared. So this is just that little triangle. I'm going to have x squared plus h squared equals 25 squared. 25 squared, that's like 625, 625, 25, I was right? Okay. So we just have x squared plus h squared equals 625. All right, that's just that little triangle. That's one of my formulas. I can't do much else with this. All right, because I have two variables. It doesn't pay to solve for one unless I know for a fact which one I want to solve for. So let's look at the bigger triangle. Our bigger triangle is a hypotenuse of 30. It's got a leg of x plus 11, and it has a leg of h. So we're just going to do our sides. So one of our sides is h squared. Other side is x plus 11 squared. And that's going to equal 30 squared. So just real quick, let's see the math on that x plus 11 times x plus 11. If I distribute my x, I come up with x squared plus 11x plus another 11x, so that's 22x. And finally, 11 times 11 is 121. All right, so realistically here we have h squared plus x squared plus 22x plus 121 equals 900. And if you're very, very clever, you don't actually even have to solve for one of those variables. We actually can use that x squared plus h squared right off the bat. And can someone tell me how I could do that? What can I do with that x squared plus h squared? Mazen?
Plug it into the equation.
I could plug it into the equation, because if we notice, I have x squared plus h squared here. Here I have h squared plus x squared, but that's the exact same thing. It's like 2 plus 3 and 3 plus 2. Those things are the exact same. So that means I can replace h squared plus x squared with 625. So I'm going to have 625 plus 22x plus 121 equals 900. All right, now we're going to subtract 121 from both sides, subtract 625 from both sides, and just so I don't mess up, I'm going to go ahead and do it here. So we're going to have 900 minus 121 minus, so we're going to come up with 22x equals 154. Then I just divide both sides by 22. And we're going to have x equals some nice number, 7. And as soon as I know that, I'm going to take this x and throw it in there. Hey, let's make sure we're paying attention to this, just in case we have it wrong. So we're going to throw that x in there, so we're going to have 7 squared plus h squared equals 625. So that's 49 plus h squared equals 625. So we're going to have h squared equals 576. And we take the square root of both of that, and that comes out to a nice 24. And if you look at what we did in the notes on number 37, we did the exact same process. All right, both those problems were the exact same thing, basically. So you just basically have to recognize when this occurs, what to do with your x squared plus h squared, and replace stuff. Okay, that's going to be up to you, is recognizing it. But like I said, I picked these problems, how to do them correctly. All right, any questions about any one of those steps that I did up there? Yep, you guys see that? Why is it not showing up? There we go, any one of those steps, I guess. Did they all make sense? Okay. Then let's quickly go on to today's lesson. It shouldn't take that long because we already did the Pythagorean theorem. Now we're going to do the converse of the Pythagorean theorem. So the Pythagorean theorem was stated that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of its legs. In other words, the Pythagorean theorem is set up like this. It basically says if I have a right triangle, so if I have a right triangle, then a squared plus b squared equals c squared. So as soon as I have a right triangle, I know that second statement is true. Quick reminder of what it means to be a converse. To be a converse, we take our if and then statements and we flip them. All right, we flip the order we say them in. So the converse of it is if the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. So where the Pythagorean theorem says if I have a right triangle, then this is true. The converse is going to be if I have a squared plus b squared equals c squared, then I have a right triangle. So we can prove that something's a right triangle just by seeing if squaring adds up to the hypotenuse or the longest side. All right, so now we can be just given sides and we can tell whether it's a right, and when we get to the next one, we'll tell if it's acute or if it's obtuse as well. But let's focus on the right triangle portion. So first of all, there's too many triangles for some reason. I must have had a stutter right then when I was typing. So is a triangle with sides 3, 4, and 5 a right triangle? Now, because these are in notes, I generally put them in order, but they will not always be in order. Yes? Oh, okay. The first thing I want you to do on these problems is locate your hypotenuse. All right, and your hypotenuse is always your biggest side. So even though they're in order, I'm going to still get in the habit of just circling my hypotenuse. All right, so that means that my sides, or my legs, are 3 and 4. So we're just going to check to see if 3 squared plus 4 squared, I'm not sure if it's equal to 5 squared yet, so we're just going to put a little blank there. All right, 3 squared is 9. 4 squared is 16. Something with 25. Well, 9 plus 16 equals 25. 25 is equal to 25. So since these two things are equal, we know it is a right triangle. Sure. We'll remember to do this. That's the big trick. Like I told the other class when I was showing them this, I'm like, these should be the easiest questions on the test. But people are going to miss them because they're going to forget to study it and they're not going to know how to set it up, or they'll forget to circle the hypotenuse and they'll try to do 3 squared plus 5 squared equals 4 squared. Got it wrong. Yeah?
Do you want us to memorize like the basic right triangles like 3, 4, 5?
We'll get to that. That's a whole other lesson. All right, is a triangle with the sides 4, 5, and 7 a right triangle? Once again, I'm going to locate my hypotenuse. In the notes section, it's pretty easy because I put them in order. In the homework, it's not in order. All right, so be aware you're looking for the biggest one. So I'm going to circle 7. So I'm going to do 4 squared plus 5 squared. That's something to do with 7 squared. Well, 4 squared is 16. Plus 5 squared is 25. 7 squared is 49. Well, this doesn't look promising. So that's going to be 41. And 49. Well, that's close. Does close count? Try to say it's close to a right triangle. Like when you're building a bridge, can you be like, meh, that's close. It can support most of the cars. I don't know. No. So this is not equal. So it's not a right triangle. But surprisingly enough, we'll see on the other page, it's important to realize that we have 41 and 49. Because 41 is less than 49, and it actually tells us something about the triangle. And we'll see that on the other side. So when I'm adding my legs and checking it compared to my hypotenuse, it's going to lead us to 3 facts. If they're equal, we know that it's going to be a right triangle. So if they're equal, when I add my legs up, and I square them, and I square my hypotenuse, and they turn out to be equal, we have a right triangle. I guess I should have is a right triangle in there. Proper English. This is an English class. It's not. My next one is if c squared is bigger than a squared plus b squared. This is where our line is too long. It's too long to make a right triangle. So can someone make a guess at what type of triangle that's going to be then? It's going to be obtuse, because if I can't draw that triangle, we'd have to basically bend this guy back so that this can lay down on top of it. So maybe not a completely accurate drawing of this would be something like this. That is too off the wall crazy. There, that's a little more accurate. Alright, so this would be 11, this would be 7, this would be 8. So our triangle is obtuse. Well, through process of elimination, what's it going to be if it's less? 2 people. We only have 3 types of triangles. There we go, there we go. Alright, Sanjeev? It's going to be acute. And it got a little awkward too. All right, and we can picture that because our hypotenuse is too small to reach the other end. So this one has to tip forward in order for it to make that proper triangle. So in other words, if I needed to rewrite this as an actual triangle, it would look something like this. Actually, not a bad one there. 6, 8. 7. Alright, so the whole thing we're going to be doing in this lesson is basically we're going to be finding out where our hypotenuse is, squaring our legs, squaring our hypotenuse, and seeing if they're equal, bigger, or smaller. That's going to be the whole bulk of it. So let's just do a couple problems here. So like I said, the first thing you're going to do is you're going to locate your hypotenuse. My hypotenuse must be 22 because that is my biggest side. So that means, yeah, go ahead. So we're going to have 22 squared has something to do with 11 squared plus 17 squared. And you may have put the 11 squared and 17 squared on this side. Just make sure you recognize which side is your hypotenuse when you are doing this math. All right. So currently we have 22 squared, which is going to be 484. That has something to do with 121 plus 289. Well, that's 484. 484, and we have 410. Well, 484 is bigger. 484 is bigger. So if my hypotenuse, remember this is my hypotenuse side. That's my hypotenuse side. My hypotenuse side is bigger. So what does that mean for that angle? It's going to be obtuse, or is it going to be acute? If it's bigger. Hannah. One more try. Obtuse. Yep. If it's bigger. Think about it this way. If our hypotenuse is bigger. Remember, bigger side means bigger angle, right? So if it's bigger than our sides, bigger leads to obtuse. It has to be longer, so it's going to be obtuse. Well, that's what I said. Just make sure you're careful about which side is your hypotenuse and which side is your legs. Your hypotenuse is going to be the big one. Is my hypotenuse big or is it too small? If it's too big, it's going to be obtuse. So that guy right there is obtuse. Okay, here's what you might want to do on a problem like this. Because who knows, just looking at 5 times square root of 3, exactly what value that is? You might be able to get close to it or get an idea. So what I would do if I had something like that, I would take out my handy dandy calculator and I would do 5 times the square root of 3. And with my calculators, this is a little different. I can show you guys that are using mine. You're going to see that's about 8.66 some number. So this right here is, I'm just going to put 8.7-ish. So that means my 10 is my biggest. I'm only doing that to check which one is my biggest side. All right? Don't just eyeball it and say, well, that's got the biggest number attached to it, so it's got to be the biggest number. Make sure you actually check in your calculator so you can sort them out. So if 10 is my biggest, that is my hypotenuse. So I'm going to put that on that side. Doesn't matter which side, but I'm just going to note that that's my hypotenuse. And my sides are 5 squared plus 5 square root of 3 squared. Just real quick, I'm going to put a little side work. Just a little side work for those of us struggling a little bit with this squaring process. Well, that's going to be 5 times 5, right? So think of this as being 5 square root of 3 times 5 square root of 3. Feel free not to write this down if you already know how to do it. I have 5 times square root of 3 times square root of 3. So 5 times 5 is 25. Square root of 3 times square root of 3 is 3. So that actually equals 75. All right, well, 10 squared is 100. That has something to do with 5 squared, which is 25, plus I did all that side work to come up with 25. Well, guess what? 100 actually equals 100. So this is going to be a right triangle. Once again, your biggest task is locate your hypotenuse and make sure you know which side your hypotenuse is on. If your hypotenuse is equal, right. If your hypotenuse is bigger, obtuse. If your hypotenuse is smaller, acute. What was that? It can be smaller when, because we're squaring everything. You'll see it in the homework. You'll definitely see it in the homework. Okay, you're just going to, it's not the smallest side, but when you square it compared to the ones added to each other, it's going to come out as, so maybe this would be 405. It'd be less than. Okay, just watch your symbol. Okay, last thing we're supposed to do is we're supposed to specify all values of x that make a possible statement true. So I guess this would be kind of an example. All right, so if I have 512 and I'm missing x and I want to figure out angle A is my right angle, I want to make that my right angle, so that means the one opposite of it is my hypotenuse. Okay, so that's my hypotenuse. So to make it a right angle, I would need x squared to actually equal a squared plus b squared. So that would be 5 squared plus 12 squared. So I'm going to have x squared equals 25 plus 144. So that'll be x squared equals 169. Take the square root of both sides, and you're going to find out that if x equals 13, you have yourself a right triangle. So if x equals 13, you have yourself a right triangle. Well, in order for it to be acute, when I square my hypotenuse, that has to be less than adding my sides. So this one's going to be when x squared is less than 5 squared plus 12 squared. Well, we already did the work. We already did this work, so I'm not going to repeat all the work. I'm just going to say this is when x is less than 13. Think about that for a second. Can it really be any value less than 13?
No.
Are there any values that don't work? Yeah.
Anything less than 0.
Anything less than or equal to 0, because you can't have a 0 side. So in your mind, we're not going to write it down, but you need to think smart about this. This is saying if it is a triangle and this side is less than 13, then it's going to be acute. We're eliminating all possibilities of being a negative number or 0. All right, right off the bat on this one. Our other one is asking when is it obtuse? Well, it's obtuse whenever x squared is bigger than that 5 squared plus 12 squared. Well, that means x, remember we already did all that work, x needs to be bigger than 13. Does that mean it could be any number bigger than 13 though, once again? Can I pick 100?
No.
Can x be 100? Can x be 100? Can x be 100? I need more people shaking their heads. Some people are still like, maybe. No, it can't be 100, because if this is 100 and I have 5 and 12, can 5 plus 12 ever equal that 100 and still be a triangle? No, they're going to hang off on the sides like this. They're not going to reach each other. Okay? So remember, to make a triangle, the sides have to be a certain size. All right? We're not going to write that there, but I want you to think about that, because that actually is in the homework. There's a question about that. All right, any questions about what we did today at all?